In this video, I will show how a monopolist with multiple production facilities maximizes profits. Here we have a monopolist who faces the following market conditions given by this inverse demand equation. The monopolist can produce this output Q from plant 1 with the following total cost structure, and from plant 2 with the following total cost structure, where these subscripts here represent which plant this output is being produced from. With this inverse demand equation, we should recognize that the total output that the monopolist produces, again, is going to come from one of these two plants. So it's just Q subscript 1 plus Q subscript 2. Okay, so the next thing we're going to do is we're going to get marginal revenue. Okay, so we can do that as follows. Total revenue equals price times quantity. Price is 100 minus 0.25 times Q, and that all is multiplied by Q. Simplifying, we get that expression. And now marginal revenue is solved for by taking the derivative of the total revenue equation. And we get 100 minus 0.5 Q. Now, in this type of problem, since Q is the output coming from plant 1 and plant 2, we're going to go ahead and substitute that fact into the marginal revenue equation. Okay, so all I did here was recognizing that Q is the output coming from plant 1 and plant 2. I make a substitution in here, and we'll just briefly go through this, simplify it one more step. And we get this expression for marginal revenue. Not quite as simple as the previous problem. However, the good news is we're going to solve these problems pretty much like all problems by setting marginal revenue equal to marginal cost. What we need now is to get marginal cost from each plant. And marginal cost here from plant 1 is the derivative of the total cost equation with respect to output. And we just get 2 Q subscript 1. Marginal cost from plant 2 is even easier. Taking the derivative of the total cost equation with respect to output, we get 20. Constant $20. So our next goal is to do the following. We're going to set marginal revenue equal to marginal cost subscript 1, and then we're going to set marginal revenue equal to marginal cost subscript 2. So let me do this on a fresh screen here. Setting marginal revenue equal to marginal cost 1, we're going to get the following result. 100 minus 0.5 Q subscript 1 minus 0.5 Q subscript 2 equals the marginal cost in plant 1, which we said was 2 Q subscript 1. What I'm going to do now is I'm going to solve this equation for Q1. And then I'm going to divide through by 2.5. and we get that following result. Let me just circle that for our attention. And now we're going to do the same thing, but this time setting marginal revenue equal to the marginal cost of plant 2. This time let's solve for Q2. Dividing through by 0.5. We get this result. Output equals 160 minus Q subscript 1. We got two equations and two unknowns. Easiest way to solve this is just substitute one equation into the other. And what you see me doing here is I'm putting this 160 minus Q subscript 1 back into this Q subscript 1 equation. Okay. And now we're going to just simplify this a little bit. And we get that result. Simplifying some more. We get the amount of output that this firm would like to produce in plant 1. To get the output in plant 2, make a substitution into that equation. And we get 150 units of output coming from plant 2. Our next thing we could do is we could solve for the profit maximizing price. The profit maximizing price is going to be P equals 100 minus 0.25 times the firm's total output, which is 10 plus 150. And this will simplify down to $60. It's going to be 100 minus 40. Okay, I hope this helped.